Imagine a battlefield, engulfed in smoke and the roar of engines. And imagine a monster, not a machine, but a predator, forged from steel and hatred. In 1943, on the boundless expanse of the Eastern Front, the name of this behemoth sounded like a death sentence: the Tiger, the German heavy tank Panzer VI, 57 tons of impenetrable armor, armed with the legendary 88mm gun. It could destroy a Soviet T-34 from 2 kilometers away, all while remaining absolutely invulnerable to return fire. For the tank crews of the Red Army, an encounter with the Tiger was a guaranteed path to hell. But amidst this nightmare, where every old Soviet gun seemed useless, where the fate of the entire war hung by a thread, the Red Army was preparing its answer. Not a new tank, not a new airstrike, but a tiny, top-secret shell capable of achieving the impossible. It left in the impenetrable armor of the German Tigers small, neat, surgically precise holes. What secret weapon shocked the Wehrmacht tankers? Unveil the mystery of the subcaliber round, a top-secret development that gave the old T-34 tanks a chance for victory at the Battle of Kursk, and became the true killer of the German beasts in the Great Patriotic War. To truly grasp the magnitude of this secret, one must first appreciate the problem. Up until 1942, the Soviet T-34 and KV tanks had delivered a technological shock to Germany. But the Wehrmacht quickly caught up, responding with the Panther and, of course, the Tiger. The Tiger I was not merely a tank, it was a mobile fortress. Its frontal armor reached 100 millimeters, positioned vertically. This was simply too much. The standard Soviet armor-piercing shell, the BR-350A, fired from the 76mm F-34 gun, the primary armament of the T-34, could penetrate a maximum of 60 to 70 millimeters at a range of 500 meters. This meant the T-34 had to close the distance to the Tiger to grenade-throwing range, 100 to 200 meters, and hit its side or rear. But the Tiger simply wouldn't allow that. It saw you 2 kilometers farther away, and its 88mm cannon left you no chance. The beginning of 1943 was a time of desperation. Soviet tank manufacturing was working at full capacity, trying to create new, more powerful guns, but this required time, and time was a luxury they did not have. On the horizon loomed the largest tank battle in history, the Battle of Kursk. And there, the Germans were planning to use Tigers by the hundreds. The Red Army needed an immediate, albeit temporary, solution. They needed a weapon that could be used right now from old, mass-produced guns, but which could pierce 100 millimeters of German steel. The answer came from an area the Germans considered a dead end, the physics of kinetic energy. In conventional armor-piercing shells, all mass and energy are distributed evenly. To penetrate thick armor is like breaking a thick wall with a sledgehammer. You need a big, heavy sledgehammer. A new Soviet gun would have been that sledgehammer. But what if instead of a sledgehammer, you used a needle? A needle that must be accelerated to an unbelievable ultimate speed. Thus was born the Armour-Piercing Composite Rigid, or APCR shell, or as the Soviets initially called it, the BPS. The secret lay in its construction. 1. The core. Instead of making the entire projectile from heavy, durable steel, the creators of the APCR took the densest material they could afford, tungsten carbide. They fashioned this into a tiny, super heavy cylinder. This was the armor-piercing Stinger. 2. The sabot, or padan. The tungsten core was too small to be fired from, say, a 76mm barrel. Therefore, it was placed in an aluminum or steel jacket, the sabot. This jacket was the full caliber of the gun, ensuring a tight fit within the barrel walls. 3. The idea. In the barrel, the gun accelerates the entire projectile, both the core and the sabot, to an unprecedented speed. But as soon as the shell leaves the muzzle, the lightweight sabot is immediately stripped away by the oncoming airflow. And this is where the magic began. Only the small yet incredibly heavy, sharp tungsten rod flew toward the target. Because its mass was many times less than that of a conventional shell, but it was accelerated to the same or even higher muzzle velocity, it retained its speed over a short distance much more effectively. This was the principle of sledgehammer versus needle. The conventional shell, or sledgehammer, has a large contact area, shock wave, and causes a lot of damage, but all its energy is dissipated across the thick layer of armor. The subcaliber shell, or needle, has a tiny contact area and a super high density of energy. All the force of the impact was concentrated into a single point. In practice, this meant that the 76mm F-34 gun, which struggled to penetrate 70mm with a standard shell, could now penetrate up to 90-100mm of vertical armor from 500 meters away. This gave it a chance to embed its needle directly into the frontal armor of a Tiger and disable it. The effect was shocking. Instead of the massive, devastated crater left by German 88mm guns, a small, neat hole, as if drilled by a machine bit, appeared on the Tiger's armor. This was pure, surgical armor penetration. Time was running out. The APCR was adopted literally on the eve of the Battle of Kursk in July 1943. It was here, on the largest tank battlefield of World War II, that the new weapon was to undergo its baptism by fire. Initially, everything went according to the German plan. Tigers, advancing in wedges, literally incinerated the Soviet defenses. Old T-34s entered the battle with sinking hearts, knowing that their only hope was maneuverability and close-range firing. But when the subcaliber rounds came into play, the situation changed. From German tanker reports of that time, we learn of growing horror. They suddenly began receiving penetrations where they shouldn't have, in the front, from a kilometer away. At first, we thought we were being hit by new heavy guns, but that was not the case. We found tiny penetrations through which the projectile had passed. It was impossible. Our tank was invulnerable. Our ammunition was jeopardized. Men were dying from small yet lethal fragments torn from the inside of the hull. This shell became a psychological weapon. German crews believed in their invulnerability, and when that belief was shattered by a thin tungsten stinger, their morale faltered. The subcaliber shell did not solve all the problems. It did not make the T-34 equal to the Tiger, but it gave the Soviet tankers something priceless, a chance. This was a chance they seized. Now, when a Tiger entered the effective firing range, around 500 meters, the Soviet T-34 could fight back. This forced the German commanders to be nervous, change their tactics, and not rush into frontal attacks as carelessly as before. Like any temporary solution, the subcaliber round had its critical drawbacks. The main one was range. The ultra-high velocity quickly dropped off, and at distances over 500 to 700 meters, penetration sharply decreased. This made the APCR exclusively a close or medium-range weapon, yet the Tiger was the perfect long-range sniper. The second drawback was the availability of tungsten. Tungsten is a rare and strategically important metal. The Red Army could not produce these shells in the same huge quantities as standard ones. They were scarce, expensive, and issued to crews in strictly limited numbers. It was the silver bullet that had to be saved for the critical moment. And the third paradoxical drawback was related to its clean operation. The APCR pierced the armor, but due to its small mass and caliber, it created fewer destructive secondary fragments inside the tank than a conventional, larger caliber shell. Sometimes a Tiger could take a hit, lose one or two crew members, but remain in the fight. Nevertheless, this shell fulfilled its historical mission. It became the crutch, the temporary measure that saved the situation. It bought the Soviet engineers time. Using the experience of APCR use and analysis of captured Tigers after Kursk, the Soviet command accelerated the development of new, more powerful guns. Soon, the T-34-85 with the 85mm gun appeared on the front, followed by the heavy IS-2 with its formidable 122mm weapon. These new guns no longer needed secret tungsten needles. They could penetrate Tigers with standard, full-caliber shells, but it was the subcaliber round that paved the way for them. The history of World War II is a history of technological races. Each side created a monster, and each side sought a way to defeat it. In this race, the German Tiger was the peak of engineering of its time, and its armor was a symbol of superiority. But the Soviet subcaliber round proved a simple truth. It is not size that matters, but the density of energy. Sometimes, to defeat Goliath, you need not a sledgehammer, but a thin yet lightning-fast stinger. This was one of the greatest technical secrets of the war, which transformed a morally outdated gun into a tiger killer and forever changed the face of the battlefield.